everyone. I am Assistant Professor Urmi Shah from ICT Department of LJIET Institute of Engineering and Technology. Today we will be starting with amplitude modulation transmitters in Amplitude Modulation Technique Unit Chapter 3. In this we will be moving ahead with more amplitude modulated transmitters and its detailed block diagram, how it is used in the recent technology that we will be seeing in this chapter. So basically, amplitude modulation scheme is a scheme in which we are varying the modulation amplitude of the signal and we are just transmitting the signal from transmitter end to receiver end by modulating or by changing its amplitude. In the amplitude variation, we are just changing its amplitude in terms of signal parameters and then we are transmitting it from one end to other end. So this is what we have seen in amplitude modulation scheme. In today's session, we will be seeing regarding what is the principle of amplitude modulation, like where we are using this amplitude modulation and why we are doing it, and moreover we will be seeing the amplitude modulated transmitters. What are amplitude modulated transmitters? What are its overall structure? That we will be seeing in this session. So basically, principle of amplitude modulation says that amplitude modulation is a process of changing the amplitude of a relatively high frequency carrier signal with respect to or with instantaneous value of modulating signal. So basically, you are having one information signal and that information signal we are changing or we are varying in terms of amplitude parameters, and then the process of changing the amplitude with respect to some high frequency carrier signal and modulating that signal instantaneously is known as amplitude modulation. Now you all might be wondering what is the input of amplitude modulation. So there are two inputs of modulation. As we are using modulator at transmitter end, that is going to transmit our signal from transmitter end to receiver end. Same way at receiver end, you have a demodulator that is going to receive your signal which has been already transmitted. So here there are two inputs of modulation device, that is a single high frequency RF carrier signal which is going to have constant amplitude, and then we have the low frequency information signal that may be a single frequency or it can be a complex waveform or it can be a combination of multiple frequencies made up of lots of frequencies passed as a single signal. So these are the principle of amplitude modulation, how the amplitude modulation is defined, what are its characteristics, and what is the range of frequency of amplitude modulation. Now we will be seeing is the transmitter section. What are transmitter made up of in amplitude modulation? So basically, transmitter concept you can see here in form of block diagram. The foundation or the licensing of this transmitter is based on the commercial equipments available to all of us. So avoiding the over deviation or operating of power amplifiers into poor matches, that can be a drawback whenever we are moving towards commercialization. So basically the transmitter is having blocks like audio block, modulator block, then RF frequency generator block and RF power amplifier block. So in the first block, as you can see, the input is coming from a mic signal. That mic is going to pass on the audio signal. So first stage is the audio stage. Input is in the form of some audio signal. Second stage is our modulator signal. In modulator, we can have different types of modulators, which can be amplitude modulator, FM modulator, and SSB modulator, that is single sideband modulator. So basically, whenever you are transmitting this audio signal into a modulator block, obviously modulator block is going to generate a modulated output, that is mixing of message signal and carrier signal. It is going to match up that signals and generate a modulated signal. So that modulated signal is passed on to RF frequency generator, and that RF frequency generator is going to generate a proper frequency range such that it can be transmitted to power amplifier. So third block is attached with the second block, and from second block we have fourth block, that is RF power amplifier. Power amplifier is going to transmit that signal from one end to another end. Let's take an example. If we have an antenna in Ahmedabad and another antenna is in Vadodara. So this Ahmedabad antenna is going to act as a transmitter and Vadodara antenna is going to act as a receiver. So between two cities we want to communicate, so directly antenna is not going to communicate. Between that we have to keep amplifier block or generator block which are going to generate and which are going to store that signal. So this is how the transmitter section works. Moving ahead, we will be seeing the receiver section also. So this is basically transmitter. Now, in the more stages, whenever you are transmitting lot of signals or lot of multiple frequency signals at a time, at that time in this transmitter signal, you have to raise the amplifier. How amplifier can be raised? By connecting it in cascaded form. In cascaded form, the efficiency of amplifier increases by a lot of amount, and here whenever I am passing any signal into modulator, modulator will have an oscillator from where the carrier signal is going to come. From modulator, the modulated signal will go to amplifier. Here in the amplifier block, we have back-to-back amplifiers connected in form of stages or in form of cascade connection. So this amplifier cascaded connection is going to give me a large amount of gain or power gain in form of signal, and that we are going to transmit over antenna from transmitter end. So this is how the transmitter block works in form of driver as well as in form of power stage. This is the receiver block. Once you are done with transmission, you need a receiver block also where you can receive your signal. So at the receiver end, we will have the receiving antenna, then we will have the low noise amplifier which is going to reduce the noise level of your signal and just filter out that noise from your message signal which is received by the receiver. So low noise amplifier is going to filter out the noise signal. Now then we have a filter if few noise frequencies or some other kind of unwanted signals are present, that filter is going to filter out those frequencies and then it will pass on to mixer. Your mixer is going to separate out the message signal and your carrier signal, which was originally combination. Modulated signal is achieved at receiver. So it is a combination of message signal and carrier signal. So that mixer is going to differentiate your message signal and carrier signal, and at the filter end, final filter end, you will have the original message signal. So this is how the receiver block works in form of low noise amplifier and gain stage amplifier. This is the block diagram of receiver. So overall block diagram of transmitter and receiver you can see over here is like this. Once the signal comes into modulator section, it is going to convert the message signal into modulated signal by mixing it with carrier signal. That modulated signal is passed on to power amplifier. and that power amplifier is going to generate the transmission signal at the antenna end, and from that antenna end we will have the flow back of receiver, that is low noise amplifier, filter, and at the end filter we will have the receiver end. So this is a combination of transmitter and receiver. So you can have here transmitter signal as well as receiver block. So it is known as transceiver block. Whenever you have a required package of transmitter and receiver in one only, at that time you can purchase transceiver block instead of buying two different blocks, that is transmitter and receiver. So this is all about transceiver block. Now next is the AM radio station. All of you have seen the radio station, or you might be hearing to radios, but have you wondered how this radio station works? In radio station we have a long antenna, steel colored antenna is there in your radio. So that steel colored stick is going to work as an antenna. So your radio is going to be an antenna with that steel stick, and from the available antennas in the current region or in the current surrounding of that radio is going to capture the frequency, and that is going to generate the noise, or it is going to generate the voice or audio signal. Surrounding of radio, there are multiple frequencies or antennas available. From the available antenna range or available frequency range of antenna, that radio is going to capture that frequency and going to generate the audio signal or voice signal. So this is the working of AM radio system. In AM radio system, you will always see two blocks, that is transmitter and receiver. So now next is this about basic analog communication system. Basically, we have seen in an analog communication system, there will be an analog input. That is, there will be an input transducer. Input transducer is going to generate the input signal. From there, the input signal is going to pass on to transmitter. From transmitter, we have a communication channel. And from communication channel, that signal is going to pass on to receiver. And that receiver block is going to generate the output at the output transducer. So this is the overall working of basic analog communication system. This is how the analog communication system works. So this we have studied it in amplitude modulation, that we will be having one message signal that is analog in nature, and we will be having one carrier signal, and mixing them we will have the modulated signal. So this is our modulated signal, this is our carrier signal, and this is our message signal. This is how the whole picture of amplitude modulation works. So we have completed this unit 3 by covering all the topics of amplitude modulation. Moving ahead, we will be seeing few more topics of modulation technique, that is frequency modulation, phase modulation. In those sessions, we will be learning how the bandwidth and the frequency range is different compared to that of amplitude modulation. This is the market available integrated circuit of amplitude transmitter. This IC is used for amplitude transmitter in market. So this is just for your knowledge how the chip is there and how it works. So we have studied it, the transmitter concept, and this IC is used for AM transmitter in market. So these are the features of AM transmitter, that they are mature enough technology, widely spread, used everywhere, and the basic examples of AM transmitters are standard AM broadcast stations, CB radios, VHF aircraft radio, that is very high frequency radios. So everywhere these AM transmitters are used. This AM transmitter is having a lot of stages of transmitter, that is power amplifier and low power levels. So it is going to have different components in terms of oscillator stage, buffer stage, multiplier stage, driver stage, and power amplifier, that is the modulator stage. So these are the various stages of AM transmitters. AM transmitters can have a frequency band of 10 kHz. That is the range of AM transmitter. It can have a band of 10 kHz, and nearly the AM transmitter have a frequency range or bandwidth range of 650 kHz to 615. That is the broadcast range. So these are all the frequency band ranges of AM transmitter. AM transmitters are used to transmit input signals such as radio signal, music, speech signal, and varying the amplitude of this signal, they are transmitted using carrier frequency by performing amplitude modulation. So this way the broadcasting of AM signal takes place from signal source to modulator to power amplifier to antenna. This is the basic block diagram of transmitter. Signal source, modulator, power amplifier and antenna. This is how the signal is passed on from one stage to another stage. So following are the reference books for this topic which we have covered today. Moving ahead, we will be seeing more amplitude modulation techniques and more modulated technique like phase modulation, frequency modulation, and we will be looking upon the applications of communication system. Thank you so much for this session or for watching this video. We will be moving ahead with a new chapter in next session. Thank you.